Now?
Yeah, whenever you're ready.
Yep.
I don't know, I feel like it's
G'day everyone and welcome to another video here. We're back in term 2 for my school. So hopefully you're back at school now as well. We've got exams in about 4 or 5 weeks, so we're working our way towards that. Still a couple of areas to cover. One is the last part on our functions area. Now I kind of put a little mark here and I'll get back to that in a minute. I said some other functions, see if you spot what I'm on about there. So we've got this last part of function stuff to do. And then we're going to move on to a couple of new topics before the exam. Hopefully you're with me on this course as well. So our first one is the square root idea that we're going to do. So a square root idea, you would know that the square root of 9 is 3, the square root of 16 is 4. That's not a big issue, that's kind of, you know, year 8, year 9 stuff, no problems there. But we've got to be careful because if I work out something like the square root of 4, really my answer is going to be plus or minus 2. Because if I go the other way and square it, minus 2 all squared gets me back to 4 as well, doesn't it? So there's really two answers that I'm getting here. Now this is where I've got to be careful about what am I being given originally when I'm looking at this square root idea. If I'm given that graph there, then actually I only take this green section of the graph. Because I'm saying I'm taking the positive version. But if I start with this one instead, and really all I've done is to square both sides of this, then that will give me actually a plus and a minus part to it. So this part here is the plus square root of x, this part here is the minus square root of x. So it's just a matter of being aware that if you got given y equals the square root of x, then that's actually only the green section. But if you start with this, then you're actually wanting both sections. So the square root of x graph, or the y squared equals x graph, is looking something like this, which you might say, doesn't that really just look like a parabola that was here, our quadratics, kind of tipped on its side? And essentially, yes, it is. Now, just as a little extra, and this is not in our course, but as a little extra, is that when we look at the inverse of a function, we reflect the function in the line y equals x. Okay, so the inverse of a function, which actually, for those who are good with their notation like this, f of x type notation, the inverse of it is f to the minus 1 of x. And when you think, if you look at this graph here, if I reflect this in this line, can you see how it would kind of just flip up that way? And it would be that quadratic? So start with the quadratic and flip it down here, or start with this and flip it up there. It's reflecting in the line y equals x, which is what our inverse functions are talking about. And again, I'm jumping ahead here a little bit. But that's just how we do link y squared equals x and y equals x squared. They're linked because one is the inverse of the other one. That's a little ahead, but there's a little extra for you. So, let's move on from that idea and the idea of square root of functions, because once you've seen this, there's not many tricks to it. All the normal things apply. So if we put a number underneath the square root sign here, then it moves it left and right. If we put a number at the end, plus or minus, it moves it up and down. And if we put a number at the front here, then it changes the shape of it. So it works in very much the same way as our quadratics do, with those extra numbers in to shift things around. We don't need to go into too much detail on these. Let's look at circles. So the formula x squared plus y squared equals r squared is the general formula for a circle. What are we doing? Well, we're squaring both of them, of course. Now, if you remember that old guy Pythagoras, when we're looking at Pythagoras, if that's 1, and I call that x and I call that y, isn't that really just the formula here? Or actually, sorry, call this r? Isn't that really just the formula there? X squared plus y squared equals r squared, if this was a right angle triangle. So if you take that idea that kind of right angle triangle, x and y square them, add them together, isn't that this idea here? That using this example, and I put 1 in so I've got a number to work with, isn't that this idea here, that this point here, with some x value, which would be that length there, and some y value, which would be that length there, and because x and y are at 90 degrees to each other, well, there's my right angle. X squared plus y squared equals 1 squared. Well, isn't that just defining that point there is a possible point that fits that equation? In a similar way, isn't this point over here also 1? Because look, the distance here was 1. And here's my y value. Now it's negative something, isn't it? But negative y all squared makes positive, doesn't it? So the negative I don't really care about. And similarly, this is negative some x distance, but again, negative x all squared is a positive answer. Don't really care. So this here, these 2 points that I've kind of worked through, they are 2 points that fit this equation. In a similar way, wouldn't this point here fit that equation? And wouldn't this point here, and this point here, and this point here, and all of these, doesn't matter which one I choose, I'm going to get some x value, some y value, and when I square those two, I will get a distance or a radius of 1. So really my circle formula is just saying choose x and y values such that when you do a bit of Pythagoras, it comes out to be whatever the radius is that we're looking at. So see circles as a formula for a set of points that are equidistant from some middle point. Now in this case it's the origin. Doesn't always play out like this. This is a bit too easy. Doesn't always play out. We know what it looks like now. Oftentimes we get this sort of thing. You might go, how am I going to tell what's going on there? Well, you've got an x squared and you've got a y squared. That's the thing that's telling you that's probably going to be a square. Notice over here, only one of them was squared. If I had a quadratic, only one of them would be squared. If they're cubed, then they're a different set of things, right? But here, x and y is squared. Yeah, there's other stuff going on in there as well, but the x and the y are both squared. That's my key. That's my key to know it's going to be a circle. Okay, so what have I done? I've just spread this out a little bit. I've created a bit of space in here and a bit of space in here. Now you'll see where I'm going with it. I'm going to complete the square on the x values. And I'm going to complete the square on the y values. So remember our rule, halve this and square it. Half of that is 1, square it, 1. So I want to put a 1 in there. Two things I could do now because this equation is different to that one up there. One thing I could do is put a -1 on this side as well. But in this case we don't normally do that. I'm going to put a +1 over here. Because think of the balance beam idea. I've added 1 over here. If I add 1 over there, it's still balanced, isn't it? Hasn't changed a thing. So that, isn't that going to factorise to x plus 1 all squared, multiply it out in your head, x times x squared, 1 times 1, 1 squared, multiply the two together and double it, there's my 2x. So this is okay. Here, halve it and square it. Where'd the negative go? Squared it didn't because it's -2 all squared, so therefore +4, and I'm going to put a +4 over there. So again, I've balanced the thing up, haven't I? No difference. Factorise this bit, isn't this going to be y -2 all squared? Multiply it out in your head, it's going to work. What's on the right hand side? What have we got? 11. Now, I'm going to write it up like this. Square root of 11 squared. Well, that's just 11, isn't it? Right? That doesn't change anything. But doesn't this now fit the format of this? So I can just read stuff straight out, can't I? Now, just like over here, I said if we put a number under here, it changes something out here, changes in front, changes. This one is affecting the centre of the circle for the x dimension. So the centre of this circle is going to be at -1, the opposite of that, and +2. That there is going to be the centre of the circle. So I've picked this circle up, I've moved it 1 this way, and I've moved it 2 up there. So that centre point has moved up here somewhere. And then the radius is no longer 1, the radius is going to be square root of 11. So that changes the size of the circle. So these two things change where the centre is. This changes how big it is.
Wait, what? I'm sorry.
These two here. Because this is controlling the x dimension. So make this 0, like we would with quadratics if we were factorising or anything like that. make this 0, the solution will be x equals minus 1. So that's where the centre of the circle has moved horizontally. Make this whole thing into 0, that means it must have moved up 2 to make it 0. And then this changes the size of it. Okay? Now, if I had negative square root of 11 in there, is that going to change anything? If I got an answer out of there and I wrote, negative square root of 11, would it change anything?
No.
Just kind of go back the other way, wouldn't you? So from the centre point, rather than going out that way, you just go back the other way. It's still going to get to the circle, isn't it? Whether you go positive or negative, it doesn't really matter which way you go. You're just looking at a distance away from the centre of the circle. So you can look at distance from the centre in some sort of positive idea or in some sort of negative idea, but you still end up on the circumference of the circle. Now, back way over here. Why did I put this here? What's wrong with this? Are these functions?
No.
Why not?
Multiple x values. Why so?
Reword that. You're right. It's not about multiple x values, but I know where you're going.
There's one x value.
One to
Many y values.
many.
Again, not quite right.
Many y values to one x value.
Yes. Yeah. There you go. You got there. You got there. So the issue here is this is not a function, because from one x value, I have the potential to get 2 y values. And remember, to be a function, it must pass the vertical line test, the one-to-one idea, right? So for one x value, one y value. All right. Now here, same thing. If I draw a vertical line, you can see it's going to cross, or it may well cross, in 2 points. If I draw the line out here, well, okay, it's not going to cross, but that doesn't solve it. Anywhere through here, it crosses twice. Okay. So the rule for being a function is it must be a one-to-one, or it can be a many-to-one. Think about that in your head. Many x values to one y value. That's okay. What's an example of that? Go with the easy one. Exactly. So this is an x value here will give me some y value, and an x value here will give me some y value. That's okay. That's a function, because it's still going to pass the vertical line test, isn't it? Right? So that is still going to be a function. So many x values to one y value, okay, it's a function, no problems. One x value to one y value, no problems, it's a function. But one x value to many y values, not okay. So these are not functions, they're relationships rather than functions. Remember way back at the start here I said about if we only had this, would that be a function? Yes, because I'm only taking the upper half, aren't I? Or if I said I only want the lower half, that's okay as well. But I can't have both parts because then it doesn't pass the vertical line test. Similarly, in the circles, I could restrict my domain or my range, and that would help me. Now, if I restricted my domain, remember domains are my x values, aren't they? If I restricted my domain, would that solve my issue of it being a relationship rather than a function? If I wanted to make it a function, could I restrict my domain and achieve that? No, I wouldn't be right, because if I say only positive x values, still going to fail the vertical line test. I mean, there is one case where I got so far to the edge there that it's virtually just a dot left, but it's hardly a function really anyway. And if I go the other way, then again, I've still got 2. So if I restricted my range, which is my output values, to only positive or only negative, that would work, wouldn't it? Because then I would be looking at only that, and it would pass the vertical line test, or only that, and it would pass the vertical line test. So just a note here, be careful, these are not functions, they're relationships, but by restricting domain or range, we can make them into functions if need be. Hopefully this video helped. Catch you later.
Oh,